So we talked about human learning. Let's talk a little bit about machine learning. So up next is going to be Larry Pizette, who's the head of Amazon Machine Learning right here in our own Boston. And he's part of a panel a little bit later on living with AI today and tomorrow with some other really top-notch folks. So welcome to the stage, Larry Pizette.
Thank you.
Thank you.
Thank you, everybody. Really appreciate the chance to come speak with you this afternoon. I lead the Amazon ML Solutions Lab. The mission of the ML Solutions Lab is to help our customers with adoption of ML workloads on AWS. We have helped over 100 customers with engagements. We work globally, and we help our customers from the ideation to building models, to training models, tuning models, validating models, and putting those models into production. When I took over the ML Solutions Lab a couple years ago, I thought it was going to be pretty similar to the customer-facing IT work that I've been doing with AWS before. In many ways, the human dynamic is the same, but there's some real learnings that we've gotten in all of these engagements that we've done that I'd like to share with you today to help with your ML engagements and roadmap. So before I jump into the ML Solutions Lab, what I'd like to share is just a little bit about ML. And this was talked about in some of the earlier sessions today, but ML is really experiencing a renaissance. Many of the ideas of machine learning have been around for decades, but there's been blockers, there's been challenges, and we're seeing those wash away now with the cloud. We can upload as much data as we need to the cloud. We can instantiate as much compute as we want to train our models as quickly as we want, and we can put them into production at massive scale. This is really important for all organizations, but particularly for startups. Startups can take advantage of the dynamic nature of the cloud, and they can try new experiments, try proofs of concept. If it doesn't work, they can fail fast and then try again so that they can ultimately succeed. And it's low cost, dynamic. ML is growing huge. We have tens of thousands of customers using machine learning on AWS. To give you an idea of the growth over the past 2 years, the number of developers using our machine learning services has grown by 7x. What I'll do today is talk about a couple of use cases in our professional sports business because I find these really interesting, but they also exemplify the learnings that we've come to understand from doing our 100+ engagements. So this is a really fun one. Working with Major League Baseball was fun, not just because it was a professional sport, but because they have a real understanding of data and statistics. When our data scientists went into MLB headquarters, it was exciting. We started working with them and came up with a model to do pitch prediction, to predict the next pitch that the pitcher was going to throw. The model worked great. We did it in about 4 weeks, but we determined that it wasn't that exciting for the television audience. And we wanted to find something extremely compelling to do. And so we went back, we iterated, we looked at this and we said, how about stolen base probability? What is the chance that the runner can steal second base from first base? Now this model is a lot more complicated. It takes the runner's speed, the prediction of the pitch, the catcher's pop time. There's all sorts of factors, but it's super exciting. What we do is we take a request from Major League Baseball. They send it to us in approximately 124 milliseconds. We send it back with 21 inferences. And as the player moves away from first base towards second base, in real time on the television, they can show you the probability that that player can successfully steal second base. It's hugely exciting and it's great visuals. It was a lot of fun to do, and it shows the power of iterating. So coming to the lessons learned. The first one is ideate on what your proofs of concepts and business objectives are going to be. The important learning here with the ideation is that when you get into the room, have the IT folks have the business leaders, but also have the folks that know where the data is. Machine learning typically takes large amounts of data. And if you don't have the data, it can be very hard to do. What we found in some enterprises are that data is in many different locations. It's curated by different people. And so when you're figuring out what your initial proofs of concept are, you need to know where the data is. The next one, you need to equip your team with the education to understand ML. Now, when we go through this with our customers, the first thought is, I need to train my developers, or I need to train my data scientists. And that's true, but the important one here is to train your business leaders that are owning those applications and systems what it means to be responsible for an ML system. It is different than a rules-based system like an accounting system, and they need to understand that as they're acquiring and adopting ML-based systems. Iterate quickly. As I was saying before at the MLB example, there's significant power to iterating. With machine learning, what happens is the data scientists will be developing models. There's many algorithms, there's lots of different features, or if you can think about it as inputs to the model that they can use. And so they'll be iterating on it, but it's important to come back and say, does this meet my business objectives? And then scale and deploy for production. When you scale and deploy for production now, models are very frequently key to enterprise operations. Super important that they're in an enterprise class service like AWS or Amazon SageMaker. When MLB went live, it was huge relief that I knew that it was running on SageMaker. My team developed it in 3 weeks, and when I said, where's it running? And they said on SageMaker, and I knew it was in multiple distributed locations. It could scale as quickly as it needed to. It was just fantastic that it was there and running in SageMaker. So now I'll share with you one more example. This is a fun one. Formula One is globally super popular. Formula One has more than 500 million fans globally. They run races in 21 countries, and in 2017, Formula One races generated $1.8 billion of revenue. Super popular, and they want to make the fan engagement super exciting. So what you saw in that video was that the machine learning model was predicting the probability that one car was going to overtake the other car. So Hamilton and Vettel were having a battle there, and there was that prediction. And then the trailing car went around on the right side, and you could see the model up there on the screen predicting that. And as viewers see that, that's an exciting use of machine learning. So I'll wrap up here with just a few takeaways. One, do a POC, but ideate with the business leaders, IT folks, and the folks that know where the data is. Train your team, but make sure you're not just training your technical folks. Make sure the business leaders know what it means to adopt a machine learning application. Iterate quickly, both with the data scientists and the business leaders, to make sure the ML workload is meeting those business objectives. And lastly, put it into production in an enterprise class capability. Thank you very much.